class CMSC205. So once again, this is Montemar of MIS class 2016 and 17. So first of the three key topics from module 678 of data communication and networking subject that I will discuss is the carrier sense multiple access. So basically it divided into two parts, which primarily focus on both collision detection. So that's for the 802.3 standard, or what we call the Ethernet, and the second one is the collision avoidance for 802.11, which simply called the wireless network. So I remember when I was studying for my CCNA exploration course and probably taking my exams by then. So you need to study the theory of technologies we basically taken for granted. So in networking. So CSMA CD, so or the carrier sense multiple access collision detection, is one of those technologies. So really it works beautifully. So you don't have even to configure it. So by learning networking, so all this kind of stuff. So when it happens, it happens. So but to be an effective network troubleshooter, in my profession as well, you have to know the Ethernet inside and out. So, and that means knowing the CSMA CD. So that is our first part for this, or the key topic for module 6. So the first Ethernet standard were, the legacy Ethernet, where it's the 10 base 5 and the 10 base 2. So network devices such as hubs, repeaters, the old repeaters, the switches were not in the picture yet. So the sole physical component of Ethernet cards before is the computers and the coaxial cable. So the cable made up of a the bus-step topology that all devices connected to a single node. So to transmit data from each other. So typically, if one of these hosts on this network wanted to send data, so that's the logic for CSMA CD. So there will be no problem. So, but when two of these hosts would send data at the same time, so a collision would occur, mainly because they send or they share a same node. And the next one would be, so a standard had to be created that would host follow rules relating when they could send data and when they could send not. So this standard, which is the carrier sense multiple access with collision detection for Ethernet. So if two of the three computers on this segment send data at the same time, collision will occur. So to avoid this scenario, so CSMA CD forces computer to what we call descend to the Ethernet segment before sending data in order to make sure that no other host on the wire is sending. So when the Ethernet segment is not busy, the device that wants to send data can do so. The sender will then continue to listen and to make sure that the sending the data didn't cause the collision. So if a collision is heard, both of the senders will send a jam signal over the Ethernet. This jam signal indicates to all other hosts or all other devices in the same collision domain on the Ethernet segment that there has been a collision. So there will be a broadcast of traffic that will send to the host. Then they should not send that the remaining of the hosts in the collision domain will not send the traffic to avoid the collision jam. So after sending the jam signal, each of the senders will wait for the a random amount of time before beginning the entire process over. So the random time helps to ensure that the two devices don't transmit simultaneously again. So primarily that's the main logic for the collision detection part. So let's proceed to the um, collision avoidance, which is the same technology that use same rules, say same set of rules in mitigating collision. So in other words, carrier sends multiple access with collision avoidance for Ethernet 802.11 standard is a multiple access method in which carrier or the carrying sensing is used, but nodes attempt to avoid collision by transmitting only when the channel is sensed to be idle. So the time frame a wireless occupies the air with a single transmission is very short. So we have a different part of wireless technologies that sharing the data. So all the devices in the BSS to share pretty well. So if, for example, if node A waits its turn to transmit one frame, then it goes silent and wait for the other access point or AP to send an acknowledgement. So there will be a handshake when sending a data. Then the node B, the receiving end, backup timer or the backup timer configure it expires, and it senses that the air is silent, so free to transmit traffic from the collision domain in the wireless. So it reserves the airtime via the RTS and CTS frames. If that option is enabled, so node B transmit its one frame and goes silent, and so on and so on. So this quick handoff of small amounts of data and the sharing of the RF space is what it seems like they are all transmitting in the parallel. So in fact, they are all sending amounts of data very quickly, and then going silent while another device reserve a small amount of time for its transmission. So that short explanation on how collision detection and collision avoidance work in both Ethernet and wireless network. So that's the first of the three points that I will discuss in this video. Hope you like it and watch my video more. Alright, hello dear viewer, this is Francis again. So I'm back. So the topic 2 that I will discuss for the data communication networking subject is about the 10 base 2 and the 10 base 5, which is also called the legacy Ethernet. So let's start with the 10 base 2. So 10 base 2, also called as the TINNet. So it's one of the two Ethernet specification used in the coaxial cable technology. So one of the most important issues to remember in an Ethernet coaxial or coax wiring scheme is the 543 rule. So 543 rule, which means or which states that you can have of the 5 cable segments connected by 5 repeaters with no more than 3 of these segments being mixings or being in a mixing segments. In the days of the coaxial cable networks, so this meant that you could have up to 3 mixing segments of 500 or 185 meters each for the 10 base 5 and the 10 base 2 respectively, populated with multiple computers and connected by 2 repeaters. So you could add 2 additional repeaters to extend the network with another 2 cable segments of 500 or 185 meter each or meter long as these were link segments connected directly to the next repeater in line with no intervening the computer's traffic. So for the 10 base 5, it is nearly identical to 10 base 2, except that it's using uses a different type of cabling and media connector. So 10 base 5 is known as the thicknet because it uses the RG8 coaxial cable. So it requires an external transceivers to attach to the network interface card of each device. So the transceiver is a device that translates the workstation digital signal to the baseband cabling format. So TINNet and UDP-enabled interface cards have it built transceivers. Nowadays it's the SFP modules and the GLCT. So only 10 base 5 thicknet network interface use external transceivers way back then. Then the NIC attaches the external transceiver using an AUI connector. So the transceiver that clamps into the thicknet cabling, which is why it is usually called the vampire tap. So the base 5 can also use as the BNC connectors. So more probably it's the same now if you have still the analog line of cable in your house. So we have the splitter there. So that's primarily focusing on 10 base 5 box wiring scheme. So the transceiver then clamps into the thicknet cabling. So first 543 rule. So when we have the 543 rule applies to thicknet, just it apply as well on the TINNet. So in addition, the minimum cable distance between each transceiver is 2.5 meters. The maximum network segment length is 500 meters for thicknet, which is 10 base 5 gets the 5 in its name. So the entire set of 5 segment cannot exceed in 2,500 meters. So you can have 100 device on a 10 base 5 network segment. So that's the key point topics for the 10 base 2 and 10 base 5 lesson. Right. So the topic 3 will primarily cover the shortest path routing. So basically we will discuss the OSPF, or the Open Shortest Path First routing. So it is an internal gateway protocol, so standardized by the IETF. So it's an open standard protocol. So most platforms are used by this kind of routing. So it's commonly used in a large enterprise networks. So even in our company uses this as our networking protocol. IGP, beside of course in the IGRP and BGP. So OSPF is a link state routing protocol providing fast convergence and excellent scalability. So each OSPF routers communication has its own routing database. So it's typically it's a very efficient in its use in using the network bandwidth. So let's discuss the shortest path first algorithm. So OSPF uses a shortest path first algorithm in order to build and calculate the shortest path to all known destination. So the shortest path is calculated with the use of the Dijkstra's algorithm. So this algorithm by itself is quite complicated. This is a very high level, simplified way of looking at the various steps of the algorithm. So as I have said a while ago, so each connection or router that from point A, point B, and point C that uses the OSPF routing has its own database to know where's the best path or the best route to send the traffic from their respective network. So upon initialization or due to any changes in the routing information, a router generates a link state advertisement or the LSA. This advertisement represents the collection of all link state routers, what's called the database. So all router exchange link state by means of shortest path tree, the destinations, the associated cost, and the next hop to reach those destinations form the IP routing table. So in case no changes in the OSPF network occur, such as the cost of a link or a network being added or deleted, so OSPF should be very quiet. So they will not flood any link state advertisement to the neighboring routers, so to avoid excessive using of the bandwidth. So any changes that occur communicated through link state packets, so the distance algorithm is recalculated in order to find the shortest path. So the algorithm places in each router at the root of the tree and calculates the shortest path to each destination based on the cumulative cost required to reach that destination. So each router will have its own view of the topology, even though all the routers will be the shortest path tree using the same link state database. So the following section indicates what is involved in the building a shortest path tree. So I hope you like my three topic on this on our subject. So thanks again, guys.